Greetings and welcome to Totality Town. In this video, we're going to do something of a review preview on some eclipse science. Without a doubt, the premier citizen science project for the 2017 total solar eclipse was the Citizen CATE experiment. However, the project actually spanned at least 3 different solar eclipses, and to some degree, it's still going. But before we dive too deep into CATE, probably a good idea to step back and explain what citizen science is. Not all high-level research is done by professional scientists. Citizen science is a general approach where a professional researcher designs a large-scale project which regular citizens can participate in some way. There are hundreds, if not thousands, of citizen science projects covering all of the different branches of science out there. If you just do a quick internet search, you're sure to see all kinds of things pop up. You can help with biological classifications. You can transcribe historical weather data from scanned documents to help improve climate models. You can even identify potential exoplanets in data where you're the first one to ever see the data. In the vast majority of cases, the project teaches what you need to know, so no science degree required. The CATE experiment was really ambitious. CATE stands for the Continental America Telescopic Eclipse Experiment. The goal was to study the sun's inner corona by creating a network of over 60 carefully spaced telescopes in the path of totality. Citizen CATE was headed up by Matt Penn, former heliophysicist at the National Solar Observatory. Now, to understand why astronomers get so excited about eclipse science, you have to understand a little bit about the structure of the sun. Just like the Earth has a core, mantle, and crust, the sun also has 3 main internal layers. The core in the center is surrounded by the radiative zone and then the convection zone. Also, just like Earth's atmosphere has several layers, so does the sun's atmosphere. There are 3 main layers. The innermost atmosphere is known as the photosphere because it gives off the vast majority of the light we see. You may also hear this referred to as the sun's surface, but that's not really accurate. It's only because we can't see anything past it or deeper than it. The sun doesn't have a surface in the way we're used to here on Earth. The second layer of the sun's atmosphere is called the chromosphere, and it only extends 2,000 kilometers above the photosphere. Now, that might sound thick at first, but when you compare it to the sun's diameter, which is 1.4 million kilometers, all of a sudden it's not so thick. The red fringes that you see in total solar eclipse images come from the chromosphere. And you can also observe the chromosphere with special dedicated solar telescopes. But the big thing about total solar eclipses is that they give us a unique opportunity to explore the sun's outermost atmosphere, the corona, which extends for millions of miles above the sun's so-called surface. The corona is so dim compared to the light from the other parts of the sun that it's incredibly difficult to observe. And you can only do this by using a coronagraph, which is a device that blocks the light from the sun's disk. The problem with this instrument is that it only allows us to see the very outer part of the corona. Now, like you see the little circle here, that's the size of the sun in the image. So we lose all of this region of the sun's corona out here. Solar eclipses are the only opportunities astronomers have to get a view of the inner corona. The Citizen CATE experiment was centered on this inner corona, and the project was a long time in the making. It actually started back in late 2014. The first step was to choose the appropriate equipment and perform a test run. And so it was that a CATE prototype found its way into the path of totality during the March 2015 total solar eclipse way up in the Faroe Islands. Fred Isbner managed to protect the equipment from the elements, and thankfully the clouds parted for literally about 30 seconds. And he was able to get this one test image. Just under a year later, Several teams traveled to Indonesia to conduct another test run in early March of 2016. And this time the goal was to conduct coordinated observations, synchronizing between the different sites and stitching their data together into a longer stretch than any one observer would experience on the land. And here we see a colorized version of the results from one of the Indonesia sites. After that, a mere 17 months later, on August 21st, 2017, over 280 volunteers at roughly 70 different observing sites, all using identical equipment, they all got data during the 90 minutes that it took for the moon's shadow to cross the United States. Volunteers included high school teachers, college teachers working with their students, as well as individual amateur astronomers. The majority of the sites acquired some great eclipse data. And here we see a high dynamic range composite image, which really shows exquisite detail in the sun's corona. There was enough data to create a brief animation of the sun's corona using images from several of the observing sites in the western US. Matt Penn's published results from the Citizen CATE experiment detailed movements of large eruptions deep within the sun's inner corona, something, again, only visible during a total solar eclipse. Although 2017 was the climax of the Citizen CATE experiment, the equipment has been used for several other projects since then. Several teams traveled to northern Chile in 2019 for the total solar eclipse there, and they pooled their data afterwards. Some of them were there to gather eclipse data on polarization in the sun's magnetic field, while others were there mostly just for the beauty of it. And that's where this month's feature image came from, using the CATE equipment. You can see a coronal mass ejection extending from the sun's limb way up there in the upper right. And that's fortunate because 2019 was close to the quietest part of the solar cycle, when CMEs are pretty rare. What eclipse science is in the works for 2024? A different team is now working on a project called CATE 2024. However, the original designer, Matt Penn, and a number of others from that core CATE 2017 group are working on a different project now. The Dynamic Eclipse Broadcast Initiative, or the DEB Initiative. It involves operating several dozen identical white light telescopes for solar observations, both inside and outside the path of totality, using updated equipment, so not the same gear as in 2017. While those inside the path of totality might have the most fun, the observers outside the path of totality play a really critical role. Their task will be to monitor activity on the sun's surface. And what that will do is allow researchers to look at how surface activity on the sun drives coronal jets and streamers, these large structures in the corona that often overlie sunspots or structures in the chromosphere. For example, the 2017 CATE experiment observed the rise and fall of this coronal jet, but the source of coronal jets is still poorly understood, and the DEB Initiative data will be exploring that, among other things. With the 2024 total solar eclipse being close to solar maximum, there should also be lots of other activity to look at. The DEB Initiative will also be conducting science in 2023. Several teams are traveling to Australia for the total solar eclipse this April to run equipment tests, and a number of sites are going to be active for the annular solar eclipse on October 14th, 2023. Primarily, it'll be a large-scale test run and public outreach and education. What makes the DEB Initiative even more unique is that it's going to broadcast all of these observations simultaneously for the public. You should be able to see the eclipse in progress at dozens of different sites displayed on a map in almost real time. Even once the solar eclipses of 2023 and 24 are done, the DEB Initiative participants are going to have the option to stay active and use the equipment for other things, like observing exoplanet transits, studying asteroids and variable stars, and you can even conduct measurements of the atmosphere's optical depth, which will help with climate change research. As of the time of this recording, the DEB Initiative is still looking for support. If any of you out there are interested in donating to Citizen Science or being an active participant in the DEB Initiative, you should reach out. Lots of the 2017 participants were teachers leading teams of their students, but there were also astronomy clubs and individuals that joined. So go to the DEB Initiative website for more details. That's all for now. Thanks again for joining me here on Totality Town.